The following is the joint probability mass function of two random variables x and y. X is taking value 0, 1 and 2. Y is also taking value 0, 1 and 2. The joint probabilities are given as 3 by 28, 9 by 28, 3 by 28, 3 by 14, 3 by 14, 0, 1 by 28, 0 and 0. The question say that which of the following statements are correct? Covariance of xy equals to 3 by 4 and expected value of x equals to expected value of y. So to calculate the covariance of xy, we know the formula of covariance xy is the joint expectation of xy and subtracted by the individual expectations of x and y. We need to calculate the joint expectation first. The formula for joint expectation is summation of x into y into pxy. So this pxy is the joint probability which are given here. These are the joint probabilities. And the values of x and y are 0, 1 and 2. So if we multiply 0 with 0, we will get 0. Then multiply with the corresponding probability 3 by 28. Plus 0 with 1, then multiply with 9 by 28. That will also give us 0. Multiply 0 with 2 and then multiply by 3 by 28. That will give 0. Multiply 1 with 0 and then multiply with 3 by 14. That will also give us 0. Multiply 1 with 1, then multiply with 3 by 14. That will give us 3 by 14. Plus multiply 1 with 2, then multiply with 0. This will also give us 0. Multiply 2 with 0 and then multiply with 1 by 28. This will also be 0. Multiply 2 with 1 and then 0. This will also be 0. And because of this, the last value will also be 0. So our joint expectation is 3 by 14. We can note this joint expectation here. A joint expectation is 3 by 14. Now let us calculate the individual expectations of x and y. We know that x is taking three values 0, 1 and 2. Now we need to know the probability of x. To calculate the marginal probability of x, we need to take sum of probabilities corresponding to values 0, 1 and 2. So if we take sum of this first row, that will give us probability of x corresponding to 0. So 3 by 28, 9 by 28, 3 by 28 will give us 15 by 28. We have to take the sum of first row. Then for 1, we have to take the sum of this second row. That will give us 6 upon 14. So to make the denominator same, we can multiply with 2 in numerator and denominator both. So we will get 12 upon 28. For x equals to 2, the probability will be 1 upon 28. Now the expected value of x will be 0 multiplied by this value, 1 multiplied by this value, 2 multiplied by this value. That we write as x into px. Okay, so this will give us 12 upon 28 plus 2 upon 28. That will be 14 upon 28. And this can be written at 1 by 2. So we can note expected value of x equals to 1 by 2. Now let us calculate the expected value of y. Now that y is taking three values 0, 1 and 2. And to calculate the marginal probability of y corresponding to 0, we have to take sum of the first column. That will give us marginal probability of y corresponding to y equals to 0. 3 by 28 plus 3 by 14 plus 1 by 28. If we take sum, then that will give us 3 plus 1 4, and if we make it 6 by 28, so that will be 3 plus 6 9, and 1 is 10. 10 by 28. For probability corresponding to y equals to 1, we have to take sum of the probabilities in column 2. 9 by 28, then 6 by 28. That will give us 15 upon 28. For y equals to 2, take the sum of column 3. That will give us 3 upon 28. Now we know that expected value of y can be calculated as summation of x into, sorry, y into py. Multiply this with this one, this with this one, this with this one. So we will get 15 upon 28 plus 6 upon 28. That will be 21 upon 28. That can be written as 3 by 4. So expected value of y equals to 3 by 4. We can notice that expected value of x and expected value of y both are not equal. So statement second is incorrect. Now to calculate the covariance between x and y, we can use the formula what is written on the top. So the joint expectation is 3 upon 14 minus the expectation of x is 1 by 2 and expectation of y is 3 upon 4. 3 upon 14 minus 3 upon 8. So if we multiply it by 4 and 4 and with 7 and 7, we will get 12 upon 56 minus 21 upon 56. Clearly the denominators are same, and when we subtract the numerator we will get a negative value, and this one is given here positive, so statement 1 is also incorrect. So option D is correct, neither 1 nor 2.